The stars will die. The galaxies will drift apart. The last black hole will vanish. And then what? Will the universe fade into darkness? Will it collapse in on itself? Or will it be ripped apart down to the very fabric of space and time? This isn't science fiction. This is modern cosmology. And it's asking the oldest question of all. How does everything end? Not just our world, not just our star, but everything, all of it. Welcome to Anantum and Beyond. And this is the end of everything. To understand the end, we must first understand the beginning. 13.8 billion years ago, the Big Bang. In an instant, space exploded outward. Time began. Particles condensed. Forces broke symmetry. And light finally escaped into the newborn universe. Over billions of years, this expanding cosmos gave rise to stars, galaxies, planets, and us. And it's that expansion, first subtle, now accelerating, that defines what happens next. Because the question of the end depends on how the universe behaves as it stretches. Our perception of time is short. A second, a day, a lifetime. Civilizations rise and fall in centuries. Stars live for billions of years. But the lifespan of the universe dwarfs all of it. 100 trillion years from now, stars will stop forming. 1 quintillion years, the last black hole will evaporate. Eventually, if nothing stops it, the universe will become cold, empty, still. Unless something else happens first. Because the universe is not just expanding, it's accelerating. And that opens up stranger possibilities. The universe is not static. It's a moving story, a cosmic symphony of gravity, time, and entropy. We don't know how it ends, but we are learning how to ask. This question, the fate of the universe, is not abstract. It ties together everything we've discovered: general relativity, quantum mechanics, thermodynamics, even dark energy, the most mysterious force we've ever measured. To look into the far future is to look deeper into what this universe truly is. So, what are the possibilities? Let's begin with the most chilling one. Heat death. It sounds violent, but it isn't. It's the quietest possible ending, not with a bang, but with an eternal whisper. The theory says this: as the universe expands, it becomes more disordered. Stars die, energy spreads out, and eventually no more useful work can be done. No light, no life, no structure, just cold, dark equilibrium, forever. It's a universe where time itself has lost meaning because nothing changes. Let's imagine the far future. 100 trillion years. Star formation stops. The universe enters the degenerate era, populated only by white dwarfs, neutron stars, and black holes. 1 quadrillion years. The last white dwarf cools into invisibility. 1 10-100 years. The last black holes evaporate via Hawking radiation. After that, nothing but subatomic particles, adrift in darkness. The universe, still expanding, would become more and more diluted, approaching absolute zero. Why does this happen? Because of the second law of thermodynamics. It states, in a closed system, entropy, disorder, always increases. Our universe is the ultimate closed system. It's been heading toward entropy from the very beginning. Every star that burns, every galaxy that collides, adds to the cosmic tally. Eventually, the universe spreads its energy so evenly, nothing can happen. No more stars, no more reactions, just equilibrium, the universe's final resting state. This is heat death, a silent, endless emptiness. If this is the fate that awaits us, it's the loneliest possible ending. No collapse, no explosion, just a steady slide into cold perfection. In this ending, nothing remains to remember the beginning. No observers, no light, no time. The ultimate paradox, a universe full of laws and beauty, ending not with drama, but with silence. But is this truly how it ends? Or could gravity change the story? If heat death is a story of dissipation, the Big Crunch is a story of reversal. It imagines a universe where gravity fights back, where the outward expansion doesn't last forever. Instead of stretching toward nothingness, everything falls inward. Galaxies, stars, even space itself. The universe doesn't die slowly, it collapses catastrophically. The Big Crunch is based on one idea, that the universe is closed. Imagine a curved cosmos, like the surface of a sphere. Expand long enough, and gravity pulls everything back together. Over time, galaxies slow, then stop, then fall inward. Eventually, matter compresses into a single dense state, like the Big Bang in reverse. A firestorm of energy, time, and collapse. A final singularity. What would this final collapse feel like? In the last billion years, galaxies begin to converge. Collisions become frequent. Cosmic microwave background gets hotter, not colder. In the final minutes, the sky turns white from heat. Atoms break down. Quantum fields destabilize. In the final second, everything, space, time, energy, collapses into one final moment. Some theories don't end with the crunch. They start again. The Big Bounce hypothesis suggests, after collapse comes expansion, a cyclic universe, one that collapses and expands again and again. Death, rebirth, eternity. But there's a problem. Current observations show expansion is not slowing down, it's speeding up. Something is pushing the universe apart. Dark energy. Heat death is slow. The Big Crunch is violent. But the Big Rip is bizarre. It proposes that the universe doesn't just end, it unravels. This is not collapse or cooling. This is a catastrophic disintegration of space, time, and structure itself. Everything held together by gravity or atomic force is ripped apart. It's driven by something we still barely understand: dark energy. In 1998, scientists discovered the universe wasn't just expanding, it was accelerating. Something was pushing galaxies apart faster and faster. They called it dark energy. No one knows what it is. We can't detect it directly. But it dominates the universe, 68% of all energy content. If dark energy's strength increases over time, just slightly, it changes everything. First, galaxy clusters unbind. Then galaxies fall apart. Then stars, planets, molecules, atoms. Even space-time itself becomes unstable. Let's follow the timeline of the Big Rip. If dark energy gets stronger, 60 million years before the end, superclusters dissolve. 1 billion years, galaxies stretch and vanish. 3 months, solar systems unbind. 30 minutes, planets disintegrate. 10-19 seconds, atoms themselves unravel. At the very end, space becomes unstable. The fabric of reality tears apart. Time itself stops making sense. This is the end of structure, the end of causality, the end of anything familiar. Even light, even space-time has no place to exist anymore. The Big Rip is terrifying, not just because of what happens, but because there is no after. No bounce, no rebirth, no continuation. A cosmos torn into unspace. But is this our destiny? Could dark energy change course? For all we know about the universe, one thing remains utterly mysterious: dark energy. It's not a particle, it's not a field, it's not something we can touch or test, yet it's everywhere. It defines how the universe evolves and how it ends. But what is it? A property of space itself? A new kind of energy field? Or a flaw in our understanding of gravity? This is not just speculation. These are live questions driving some of the most advanced science on Earth. What if dark energy isn't constant? Some theories say it could fade over time, leading to a big crunch. Others suggest it could fluctuate violently, causing a sudden rip. Or perhaps the universe doesn't have a single fate at all. Maybe ours is one of countless universes, each with different physics, different endings. In some, the cosmos cycles forever. In others, it collapses in moments. Welcome to the multiverse. Cosmology isn't just about how everything ends. It's about what we can know. We're temporary creatures, studying something eternal. We live inside this mystery, using photons from 13.8 billion years ago to model futures trillions of years away. But there are limits, horizons we may never see beyond, forces we may never master. Still, we look. Still, we ask. So, how does the universe end? We don't know. Not yet. Maybe it will fade away, cold and empty. Maybe it will collapse into fire and pressure. Maybe it will shatter, leaving nothing behind. But maybe it doesn't end at all. Maybe what we think of as the end is just one turn in a cycle, or one path among billions. We're not here to predict it with certainty. We're here to understand what could be. Because to ask how the universe ends is to understand how precious it is that we are here, now, asking.
Thank you for watching. This is Anantum and Beyond, signing off.